Hi, today we are going to talk about GameObjects and components. Here in the hierarchy we already have some GameObjects, the camera, directional light, the ground and the avatar. Very well. When we click on one of them, in the inspector we see all the components it is made of. For instance, the ground, that is this orange plane, has a transform component, a mesh filter for the plane component. That is, mesh filter is like a database of triangles, that is the triangles this plane is made of. Then the mesh renderer is the component that reads the triangles in the mesh filter and draws them on the screen. For instance, if I disable this component, like I uncheck it, see it disappears. I can still see the triangles just as like a skeletal, but is not rendered, right? So if I press play here in the game view, I cannot see the plane. It is there, it's just not visible, okay? And so I can add it back. Then a mesh collider for, in case I want to use collisions and things like that, not necessary now. And then of course there is the material that specifies what shader it is using, which rendering pipeline is using, and then the parameters that make sense in the shader, for instance the color in this case. Now, the transform is always the first component at the top, and the material is always the last thing below the last component. So if the mesh collider happens to be the last component at the bottom, the material is below it. Not all GameObjects have necessarily material, but all of them have a transform component. And just to drive home the point, let me right click in the hierarchy and select create empty. As you can see, there is a transform in here. So it's not quite as empty as we may have expected, because after all there is a component in it. So it's not just an empty shell, it's not just the GameObject as a container of components, sure, plus we have to also know that there is always at least one component that is the transform. Notice that when I go in the hamburger menu of this component, the remove component option is not even there. Again, we cannot remove it, because in Unity, for an object to be a GameObject, must be in the game world. That means must have a position inside it, must have a rotation, an orientation, if you prefer to call it that way, and a scale. If it didn't have it, it would be an object, but not a game object. It wouldn't be part of the game world. So you can create objects in Unity that are plain CSharp scripts, but if you want a game object to have components, those components have to derive from mono behavior. So let me give you an idea of what we are talking about. This is it. This script is a public class called rotate, and then there is a colon that means derives. That's what CSharp syntax means. And then mono behavior. Mono behavior is a very special base class that we derive from our classes so that they can be used as components. If this wasn't there, this would be a perfectly legitimate class. It would compile even, but I wouldn't be able to drag and drop the file that contains this class onto a GameObject and expect to see it appear in the inspector. It wouldn't do it. Unity would refuse, because in a sense the plumbing that allows it to hook to a GameObject, it wouldn't be there. So we definitely want to derive from mono behavior if you want it to be a component. In this case, rotate is something that we want to drag and drop onto the cube, for instance, and have it spin. So for instance, in this case, it has a data that is a public float called rotation speed, and then we call transform rotate vertical rotation. So the axis is this one, so the rotation will happen like this, and then says rotation speed as usual times time to delta time. So we go back to Unity, and what we see? We see that, okay, we can eliminate now this empty GameObject I created just to show you that all GameObjects have at least a transform. And we go back to the avatar. As you can see, I had already moved the rotate component onto it, but let me do it also a second time. So the second one, of course, the rotation is 0 because that's the default for floating point numbers. I could give it a value, but it wouldn't make sense. Let's say I want to I want the cube to rotate at 150 degrees per second, I wouldn't have to make two scripts, 100, 150. I would simply eliminate one of the two, remove component, and then make the other 150, right? In this case, at least. Well, so now when I press play, the rotate component is on the cube, so the code that says transform, rotate, vertical axis, vector 3 up, rot speed times time dot delta time produces this effect, all right? So what if I say minus 150? It will rotate counterclockwise, right? So positive is clockwise, negative is counterclockwise. And what else do we have to say? Well, what if there is a syntax error in a script? Well, then it would sort of disappear. Let's say now I introduce a syntax error in this script that is already part of a GameObject. For instance, the word class, I break it into two parts, so of course it doesn't make any more sense. And there you go. So, and now if I press play, it even refuses because, you know, there are errors. And I am using this one. So maybe if I remove it, it may still refuse. Yeah. Just because there is a script at all, even if it's not being used, that has a bug, doesn't compile, then it refuses to play. So I Control Z here, I Control S to save, I go back to Unity, automatically detects that the file changed, it recompiles it. Now the error should be gone. Of course, now I have eliminated the component rotate, so it won't rotate, right? Nothing. As you can see, it doesn't do anything. So let's stop. Let's drag and drop it back into it. Of course, if it is 0, when I press play, the rotation speed is 0, so it won't rotate at all again. But while it is playing, one of the nice things of Unity is that you can modify the public parameters in a component that, by the way, they all are exposed just because they're public, and run them. Now when I stop, I lose it. It goes back to 0 because that's the value it had before I played. But now I know that 100 is a good value that I like, so I know I can add it back. So let's say that there were more than one parameter to remember that I modified while playing, and there are like a combination of, let's say, 5 parameters, and they are exactly the way I like them that way. I could either with my mobile phone take a snapshot and then I look at it and I retype them. Or I could go here while it is playing and say copy component. So for instance, I play. Now I only have one, so obviously I would be able to remember it. But let's say that I actually think it is too slow and I want to make it 150. Okay. I know that if I press stop, it goes back to 100, but while it is playing, I can say copy component. Now when I stop, it does go back to 100, but I don't have to remember. So let's say that instead of only one parameter, there were like 5. When I say paste component values, see, it goes to 150. And if there were, like, say, 4 more parameters, they would also have the value back to when it was playing. The values that I chose while playing, I tweaked them, right? And pretty much the last thing I want you to know is that a component, again, is a C# script. And the file name has to be the same as the class name. So let me show you again. Let's go back to Visual Studio. As you can see, the name is rotate with a capital R, right? And now we go back to Unity. The name is rotate with a capital R. So why the file name has to be like this? Well, it doesn't, strictly speaking. The class name doesn't have to have any special name, but by convention in C#, class names use camel notation. That means if they are made of multiple words, like say rotate the cube, the R in rotate, the T in the, and the C in cube would have to be capitalized. Let me show you what I mean. Rotate the cube. This is called camel notation because the capitalized letters look like the hump on the back of a camel, right? And well, they ease reading because it's easier to see when a word ends and the next one starts. And it is also the convention that classes are named in C#. And so because in Unity file names, C# script names have to be the same as the class name, we follow the same camel notation rule in here. In this case, there is only one word, fine, then it will be the only one that has a capitalized letter. And pretty much that's it as far as GameObjects, components, transforms, and all that entails. I hope that was useful. So as usual, file save project so I don't lose work. And this is enough for today. Thank you.